Hello everyone. Today we are going to solve the problem max value permutation. So it is a difficulty easy question. So the question is given an array ARR of integers. So our task is to write a program to find the maximum value of summation of array of I into I, where I is equals to the index of the array and we are allowed to rearrange the elements of the array. So note is, since the output could be larger than the integer range, so we should print the answer of modulo 10 to the power of 9 plus 7. So that is what I said. So sample input is IRR is equals to 53241. So if we rearrange them in the other order, which is ascending order, 1 2 3 4 5, so like that. So we will discuss later during the explanation of sample input. So the expected complexities are n log n and 1. So for this particular question, now let us just take an example and explain how we need to solve. So now we can see the given array was this was a given array 53241. So we need to find the maximum possible value of summation of some array of I into I. So how to do that? So our logic is, if you think, when we sort the elements in the ascending order, the least possible index will be multiplied with the least possible value only, and the maximum possible index will be multiplied with highest value only. So like that continuously. So this is going to be our maximum possible sum value. So how to do that? So they said we could rearrange the elements. So our first step is to sort the array. So array will become, after sorting in ascending order, 1 2 3 4 5. So now we can say the first step is completed. So next we will be doing just initialize a normal variable, which is a mod value, which we need to multiply mod with, which is a 10 to the power of 9 plus 7. 1 2 3 4 5 6 7 8. So this is the mod value which we need to do the modular operation with the last computed sum. So also we initialize another value, which is a sum, which stores the sum of the array as they said. So they are the two variables. So now we iterate each by index. So how we will be doing? So let us write the array here. Sorry. So what was our array? After the sorting, it is 1 2 3 4 5. So this is the array. So at the beginning, if you see, the sum is 0. So now we also write the index values, which is 0 1 2 3 4. These are the I values at each index. So now we will be multiplying these values like this. Multiply the index with its current element at that index. So after the multiplication, we will be getting the answer. So if you compute for this example, 0 into 1 is 0, plus 2 into 1 is 2, plus 3 into 2 is 6, plus 4 3 are 12, plus 4 5 are 20. So now if you compute, 0 plus 2, 2, 2 plus 6, 8, 8 plus 12, 20, so 40. So our answer is 40. So it is a smaller number, that is why we didn't perform any operation, but we will actually perform like this. So at each index, after computing the sum, we will be doing sum modulo mod value. The mod value is already initialized in the variable. So like this, the mod value will be used in our code. So this is how we are going to solve this program. So we sort the array, we take two variables, we multiply using a loop by iterating each index, we compute the total sum value, and at last the answer is the sum value. So internally we will be performing this mod operation during the computing of sum only. So this is how we are going to solve this program. So now let's see how to convert this logic into actual code. So this was the question. So if you see, we said we will be sorting the array first. So there is a method inbuilt which is arrays.sort. So after sorting, we said we will be taking two values, which is mod value, which is equals to 10 to the 1, 2, 3, 4, 5, 6, 7, 8. This is the mod value. And we also said, so if it will be a possibly larger value than the integer. Later we will be converting that value into the actual integer only. So now let us take a bigger, like a bucket which is long of 8 bytes. So now we will take a loop which we set as a third step, which is the computing of sum. So int I is equals to 0, I less than, how to get the array length, array name dot length parameter I plus plus. So after this, we said the sum value will be, sum is equals to sum plus, we said we will be multiplying the index and the value at that current I value, and also perform the mod operation there only. So array of I, so let's convert it into the long of array of I into I. This all will be modulo mod value. So at last return the integer value of the long sum value. So if you see, the sample test case is passed. We also computed here, which was the answer equals to 40, and we can see it is matching here. So now let's run the hidden test cases. So we can see there is a small error. So now we will be rectifying this error. So they said we need to cap the value. Also what we did here, using the loop, we can say we capped the value, like we use the long of array of I, and continuously we capped the value to the below than the mod value. So also again we are getting that error. So now if you see, observe, we took the sorting step correctly, and also the max value was also initialized correctly. So now the loop was also written correctly. If you see, array dot length, and now the sum was that sum is equals to sum plus. So we said we will be keep making the mod of the whole value. So we just missed that step, which was we need to mod the whole value such that after adding that value, the whole value will be inside the mod range only. So that was the small error we did. So what it is, we'll compute the value into index value and add it to the existing sum, and we'll be modding that whole value to check if that the value is exceeding the integer range or the given range or not. So if it exceeds, the mod value will be initialized. So like that. So now we'll be analyzing the time and space complexity. So this line takes a time of, we all know, the inbuilt sorting methods for any collection or arrays will take off big O of n log n. So if you go in detail for a small knowledge purpose, the inbuilt arrays.sort method uses the double pivot quick search. Double pivot quick sort method which it uses. So now this space, if you see, it is big O of n. So it is a normal variable. So it is also big O of n. So this loops take big O of n because you can see it is a loop which depending on the size of array. So we are returning. So finally the time will be maximum of the all time. So the maximum possible value of the time complexity which we see here is the sort method's time complexity. So the time will be n log n. So if you see space, the maximum space at any line is already big O of 1. So now you need to compare. So this is it. So the time complexity is big O of n log n, which is also equal to here, and the space is big O of 1. So they are matching. So this is the best optimized approach to solve this program. So kindly go and practice the program. The program link is given in the description. Thank you for watching. Subscribe for more videos.